So this is the second video dealing with inorganic nomenclature or chemical naming, and in this case we're going to we're going to cover the covalent compounds, otherwise known as the prefix system. So why don't we have a look at the prefix system? So prefix system deals with specifically two nonmetals. Okay, so this is when you use the system only. Two nonmetals, and in both the formula and the name, in terms of ordering things, the least electronegative nonmetal precedes the more electronegative nonmetal. Basically, the less electronegative goes first, the more electronegative goes second. The ending is always "-ide", just like with ionic compounds, and then the ending. That "-ide" ending is going to go on the end of the more electronegative element. And we do not have to worry about the zero-sum rule with the prefix system. So it's a little simpler. In fact, the prefix system is very simple, as you're going to see. So this particular spinning molecule up here could represent something like CO2. And so CO2 is two nonmetals, carbon and oxygen, and they're joined together by a covalent bond. So this is the distinction. This is not ionic, it's covalent. Alright, first thing you have to remember or need to realize or come to terms with are the prefixes you're going to use. So the prefixes 1 to 10, which you have already seen, are as such. So mono, di, tri, tetra, that's 1 to 5, hexa, hepta, octa, nona, that's 6 to 10. So these are the prefixes that are going to precede the name to indicate how many there are. As we just dealt with, carbon dioxide. So the di meant 2 times oxygen. So that's what those prefixes are, how those prefixes are used. So using a prefix system, given a formula, write the name. Well, actually, just again to remind you, this is really easy. You don't have to worry too much about this one. So given a formula, simply write the name. So the formula is CO2, so carbon, di, prefix for 2 oxygens, oxide. The second or more electronegative nonmetal ending in IDE. Now notice, we don't put a prefix in front of the carbon here. When there's only one of the less electronegative element or first element, electronegative element, no prefix is used. You don't use the prefix mono. No prefix is required because the fact that you've written a single C, for example, implies that there's one. Okay, so again, CO, we don't need a prefix for the carbon because there's only one of them, so there it is, carbon. But we still need a prefix for the second one, so that's monoxide. So just a little quick note here. Notice it's monoxide, it's not monoxide. So we drop the O of the mono. We never would drop the O of the oxide because oxide is part of the name of the chemical, of the element. And finally, N2O. So in this case, we do have 2 for that first or less electronegative element. So we need a di, so that becomes di, nitrogen. 1 oxygen, we still need the mono, monoxide. So, as I said, it's pretty simple. Given a formula, just write it down using the prefixes to indicate how many elements you see in the formula. Well, just as simple to write the formula given the name. So nitrogen monoxide. Well, there's a single nitrogen. There it is. There's only 1 oxygen, mono. So there's the formula, nitrogen monoxide. Carbon tetrachloride. Carbon, tetra. The prefix tetra implies 4, Cl4. Phosphorus pentachloride. Phosphorus, P. Penta is 5, Cl5. Okay, so that's about it. As you can see, this system is really easy but it applies only to binary covalent compounds, and it still requires practice. You do have to come to terms with those prefixes. The only issue people have with the prefix system is they find it so easy they want to use it all the time. But it's never used for ionic, it's never used with polyatomic ions, it's only used for binary, non-metal, or binary covalent interactions. And that concludes this video.